Welcome back. Let's do question 3. A circle with radius 6 centimeters is drawn. A second smaller circle is drawn through the center of the circle and also touches the first circle internally as shown in the diagram. So it means we have the first circle which is having a radius of 6 centimeters. So it means from there up to there, that is 6 centimeters, right? And then, so it means for the second circle, the whole diameter is what? Is 6 centimeters. What is its radius? Its radius is going to be 3 centimeters, which is half of the 6. And then we have the smaller circle, which has a diameter of 3. So meaning that its radius is 1,5. Remember, radius is half of diameter. So if I can write the radii as a sequence, we are having 6, 3, 1,5 like that. That's how the sequence is. All right, let's do 3.1. Write down the radius of the third circle. I think we've answered that. So radius of third circle is 1,5 centimeters. This is like T1, T2, T3. So radius of the third circle is 1,5 centimeters. Right, let's do question 3.2. 3.2 says calculate the sum of the areas of the first 10 circles. Please take note, we're talking about the areas of the circle. Remember, area of a circle is equal to pi times radius squared. So meaning that the first circle is going to be pi times 6 squared. The second one is going to be pi times 3 squared. And then the third one is going to be 1,5 as a fraction is 3 over 2. So it's going to be pi times 3 over 2 squared. We're having a sequence like this. 36 pi, 9 pi, then 9 over 4 pi like that. And then if you check, this sequence is also geometric. But what is the common ratio here? If you say 9 pi over 36 pi, we get what? We get 1 over 4. Even if you say 9 over 4 pi divided by 9 pi, is going to be 9 pi over 4, then times 1 over 9 pi, like this. Tip and times, because 9 pi is just the same as 9 pi over 1. And then tip and times, 9 pi divided by 9 pi is 1. We remain with 1 over 4. The common ratio here is 1 over 4. So it says, calculate the sum of the areas of the first 10 circles. So we're going to use the formula Sn is equal to A r to the power n minus 1 over r minus 1. The sum of the first 10 terms is going to be, our A is 36 pi. Okay, this is our first term, and then r is 1 over 4, and then to the power 10 minus 1, like this, divided by 1 over 4 minus 1, like this. And then you can put this in the calculator. What do you get? You get 150,7963036, and then which is like 150,80 square centimeters if we round off to 2 decimal places. All right, and then let's do question 3.3. I'll do it here. So it says, which circle has a diameter of 3 over 128 centimeters? So it's circle number what? So it's like, it's term number what? So we're using Tn is equal to A times r to the power n minus 1. So the term in the sequence should be the 3 over 128 is equal to, our A is what? What is the diameter? Take note here. Diameter of the first circle. So the sequence for the diameter will be like 12, 6, 3, going on like that. That is for the diameter. Right, so it means A is 12, and then our R, 6 divided by 12, that is 1 over 2. 3 divided by 6 is 1 over 2. So it means our ratio is 1 over 2. So it's going to be times 1 over 2 to the power n minus 1. right? Divide by 12 on both sides of the equation. So it becomes 3 over 128, and then divided by 12 is like saying times 1 over 12 is equal to 1 over 2 to the power n minus 1. Then this will give us what? Will give us 1 over 512 is equal to 1 over 2 to the power n minus 1. There are two ways of doing this using our exponential equations. So we can say 5 over 512 is 2 to the power 9. So if you say 1 over 2 to the power 9 is equal to 1 over 2 to the power n minus 1. This is just the same as 1 over 2 to the power 9 is equal to 1 over 2 to the power n minus 1. Therefore, 9 is equal to n minus 1. Then add 1 on both sides of the equation. N is equal to 10. That's the answer there. So it means a circle with a diameter of 3 over 128 will be circle number 10. The other thing we can do when we get to this stage here, we can change from exponential form to logarithmic form. Remember, if you're changing exponential form to logarithmic form, the exponent becomes the subject. So it's n minus 1 is equal to log, and then this is the base. All right, so it's going to be 1 over 2, and then the number there is 1 over 512. You just put this in the calculator, look for this function in your calculator, and then you put these things as they are. You'll get that n minus 1, which is this, is equal to 9. Then you add 1 on both sides of the equation, you get n is equal to 10.